Hello students, on the last turn we have started chemical properties of metals, and in that we have discussed first chemical property of metals, that was reaction of metals with oxygen. In this first of all we have discussed that most of the metals react with oxygen of air and form their oxides. Some metals react with oxygen even at room temperature, and some react on heating, whereas still others react only on prolonged heating. Mean they react when they heated for long time. We have given the example that sodium metal react with oxygen at room temperature and form sodium oxide. Sodium oxide, this is a basic oxide, and it dissolve in water to form sodium hydroxide, that is an alkali. Alkali, as we know, it is a base dissolved in water. So, the reaction that takes place in case of sodium, that is Na plus O2 Na2O. Balance the equations yourself. Then when this Na2O react with water, it form NaOH, sodium hydroxide, that is an alkali. So, this we have discussed earlier. Beside that, on the last turn we have discussed about the other metals like potassium, calcium. These also react with cold, these also react at room temperature, but magnesium, as it was given in activity 3.8, it react with oxygen of air on heating. Mean when magnesium is heated in air, it react with oxygen of air and form magnesium oxide. Beside that, we see a dazzling flame, white flame, when magnesium is heated to its ignition temperature, mean the temperature at which it starts burning. And magnesium, it does not react with air at room temperature. So, reaction that takes place is like that, Mg plus O2 MgO, magnesium oxide. Next we have talked about copper and iron. Copper and iron, they also react with air, but on prolonged heating, mean when they are heated for long time, and the reaction of them, both of them is like that, Cu plus O2, copper and we are taking the example of copper and iron. Cu plus O2, it react and form CuO, copper oxide, and cupric oxide. This is cupric oxide. And Fe, mean iron, react with O2 and form Fe2O3, that is ferric oxide. So, by these examples we can say metals react with oxygen and form metal oxides. Now, second chemical property of metals is that reaction with water. More reactive metals react with water at room temperature, but less reactive metals react on heating with water or steam. But hydrogen is formed in all these cases. For example, potassium and sodium, they both react with cold water. When Na and K, they both react with cold water cold water and form their hydroxide. Beside that, hydrogen is removed. In both cases, their hydroxide is formed. This is sodium hydroxide and this is potassium hydroxide. So, sodium and potassium, they both react with water, with cold water, and in this case reaction is very violent and exothermic reaction means a lot of energy is produced. Beside that, calcium, it also react with water with cold water and form calcium hydroxide, CaOH whole twice, and hydrogen is released. This is calcium hydroxide. So, sodium, potassium and calcium, they react with water, with cold water. Magnesium, it react with hot water. Magnesium react with hot water, or we can say when hot water is heated, it react, and this forms MgO plus H2. Aluminium, iron and zinc do not react with cold water, but they react with steam, and the reactions of all of them are as follows. Reactions are aluminium plus H2O, then zinc and Fe. They all react with steam, and their reaction is like that. Aluminium, when it react with water, steam, it form Al2O3 plus hydrogen is released, ZNO plus H2, and this Fe3O4 plus H2. So, in these all reactions, their oxides are formed, aluminium oxide, then zinc oxide and then ferrous oxide. These are formed. Beside that, hydrogen is released. Now, metals like lead, copper, silver and gold, they do not react even with steam. An activity related to this reaction of metals with the water is given on page number 42, and the activity is 3.10. In this activity, it is given, if we take small pieces of metals and put them separately in beakers that are half filled with cold water, we observe that sodium, potassium and calcium react with cold water, and beside that, sodium and potassium, they both catch fire on water, because the reaction between sodium and water and calcium and water is very violent and exothermic, and hydrogen evolved, hydrogen that evolved during the reaction immediately catch fire. In case of calcium, although it also react with cold water, but its reaction with water is less violent than sodium and potassium, and after the completion of reaction, it is observed that calcium starts floating, because the bubbles of hydrogen gas formed in reaction stick to its surface. So, that is why it starts floating. Magnesium, as we have done in reaction earlier, it react with hot water, The reaction between magnesium and water is not violent, but magnesium also starts floating due to the bubbles of hydrogen gas produced in the reaction, and due to this the magnesium oxide also starts floating due to bubbles of hydrogen gas sticking to its surface. Beside that, the metals like aluminum, iron and zinc, they react with steam and form their oxides, and hydrogen is also released. The metals like copper, silver and gold do not react even with steam, and overall reactivity of metals with water decreases in the order. The order is like that: potassium is more reactive than sodium, sodium is more reactive than calcium, calcium is more reactive than magnesium, and magnesium is more reactive than aluminum, aluminum than zinc, and zinc than iron. So, this is the reactivity series. Now, third chemical property of metals is reaction of metals with dilute acids. Many metals react with dilute acid to give metal, salt and hydrogen, and the reaction of metal with acid that we have done earlier in the chapter acid, bases and salts. The reaction is like that: metal plus dilute acid, it form salt, metal salt plus hydrogen. This acid, dilute acid, can be HCl, H2SO4. So, the reaction of metals with dilute acid, all metals do not react in the same manner. For this also an activity is given on page number 44, and that is activity 3.11. In this activity, it is given that sodium and potassium are very reactive metals, as they react vigorously even with cold water. So, we do not have to take these to react with acids. Now, in this activity it is given we have to take samples of less reactive metals like magnesium, then aluminum, zinc and iron, etc. So, reactions that takes place with acid are all like that: magnesium, then aluminum, then zinc and Fe. These all react with dilute HCl. Mean reaction of these all with dilute HCl, it form MgCl2, magnesium chloride, then aluminum chloride and zinc chloride and this ferric chloride. Beside that, H2 hydrogen is produced in the reaction. So, we see in these metals, they all react with these dilute HCl and form their chloride. Beside that, hydrogen is produced. In all these cases, it is also seen that in the activity as it is given, when we put them separately, when we put magnesium, aluminum, zinc and iron separately in the test tube containing dilute HCl, we observe the reaction starts in each test tube and bubbles or effervescences starts forming, but the rate of formation of bubbles is fastest in case of magnesium. Magnesium is more reactive than other metals, and the reaction of aluminum, zinc and iron is fast, but in control, and no bubbles are seen in all these cases. The reaction with H2SO4, dilute H2SO4 is like the same. As we see in case of magnesium, aluminum, zinc and iron, when they react with hydrochloric acid or dilute HCl, they form chlorides, metal chlorides and hydrogen. But in case of sulfuric acid or H2SO4, they form metal sulfates, and beside that hydrogen is produced. Now, in case of dilute HNO3, when a metal react with the nitric acid, hydrogen gas is not produced. As we are saying that in case of dilute HCl or H2SO4, hydrogen is produced, but in case of HNO3 or nitric acid, hydrogen gas is not evolved, because nitric acid is an oxidizing agent and it reacts differently. It oxidizes the H2 produced to water, H2 produced to water, and itself get reduced to any of nitrogen oxide. These nitrogen oxides are NO2, N2O or NO. But in case of magnesium and manganese, they can react with dilute, very dilute HNO3, mean 1% of HNO3 plus 99% of water. They can react with these and can evolve hydrogen gas. The reaction in case of magnesium and manganese is like that: Mg plus HNO3, dilute, very dilute HNO3, and Mn plus dilute HNO3. It forms MgNO3 whole twice magnesium nitrate. Beside that H2 is produced. In this case, MnNO3 whole twice plus H2. This is magnesium nitrate. And this is manganese nitrate. Means dilute H2SO4 and HCl can form chloride, metal chloride or metal sulfates, but nitric acid cannot make it with all the metals. Now, reaction of metals with salt solution. The activity related to this is given on page number 44, activity 3.12, and this is the how do metals react with solution of other metal salts. In this activity, it is given when we take a copper wire and an iron nail and put the copper wire in a solution of iron sulfate and iron nail in a solution of copper sulfate. That are taken in test tubes, mean copper sulfate and iron sulfate, that are taken in separate test tubes, and in both, in copper sulfate we will put iron nail, and in iron sulfate we will put copper sulfate. Then keep them for 20 minutes, and after keeping them in that condition for 20 minutes, we observe the reaction occurs in test tube in which iron nail is placed. Mean in both the test tube reaction does not go, it goes only in test tube where in which iron nail is placed in solution of copper sulphate. And we see the blue color of copper sulphate solution starts fading, but in other test tube there is no reaction occur. This activity proves that iron is more reactive than copper, and beside that the reaction that takes place in this case is displacement reaction. That the reaction that takes place is in this form Fe, that is in solid form. We have taken iron nail and we have put it into copper sulphate solution, that is blue color solution, and the reaction that takes place is like that FeSO4 plus Cu, when ferrous sulphate is formed and copper is separated. So, in this activity it is proved that iron is more reactive than copper, and reaction takes place in this case is displacement reaction, where here we see iron has displaced copper from its solution. Now, after the reaction of metals, as we have seen reaction of metals with oxygen, water and acids, we have observed that all metals not equally reactive, but after the displacement reaction of metals from their salt solution, this reaction gives better evidence about the reactivity of metals, and it is simple and easy. If metal A displaces metal B from its solution, it is more reactive than metal B. So, on the basis of displacement reaction, we can find better evidence about the comparative reactivity of one metal with respect to another. So, that is all for today. We have discussed all the chemical properties of metals. On next turn, we will talk about chemical properties of non-metals. That is all for today. Thanks.